Hi everyone, good to be back with old friends here. Love the name of the event. And so today I would like to talk to you about Web3 infrastructure, but more precisely about building Web3's decentralized backend. That's what we are trying to do at Gelato. Agenda-wise, the talk is structured in 3 different sections. One is more about sort of like a couple of my learnings over the past couple of months when talking to a bunch of different Web3 projects about the architecture, how they actually work, and sort of like a high level. I'm not going into too much detail. And then sort of what we do or how we see ourselves as Gelato fit into this sort of stack. And then I'm giving you a bit more details about sort of our newest feature that we recently released, which is leveraging off-chain data and computation to automate transactions. We'll go into more detail about that later. But yeah, let's start with the first part of the talk, the architecture of Web3 applications. This is sort of like a fairly high-level overview of an example application, which is a real-life example. This is a NFT car racing game. Most Web3 applications today, they sort of consist of 4 different parts. One of the parts is sort of like the client side, which is the browser, the front end. This might be hosted on like a serverless environment platform or like a IPFS, for example, written in React. And then you have this off-chain backend that usually projects are running themselves. And it consists of like 2 parts most of the time. There's on the left side, on the right side for you, there is the read side, and then on the other side is the write side. And then there is the on-chain stuff. And the on-chain stuff is basically just like the blockchain that you interact with, might be Ethereum, where you define your business logic and smart contracts. These are run on, for example, an Ethereum virtual machine. And then the logic is executed there, and you talk, you communicate, you read and write to that network using usually like RPC providers, or you might run your own node. But usually applications use RPC providers. And on the read side, for example, in this example, what does so like this read part of the server side of this application do? For example, in this case of this NFT car racing game, you want to read the ownership history of certain NFTs, right? You want to display, hey, this person was the owner at that time, this person was the owner at that time. You want to show statistics about a particular user, which might be, hey, this user entered the race, he won, he lost, she entered the race, and so on. And then you want to discuss racing outcomes, for example, who won the prize, etc. And then on the right side, you're actually running servers. This might be like a Node.js server, for example, that actually runs computation on that data that they have to use. That computation tries to basically programmatically write to the chain, right? You want to, let's say, help the users mint new NFTs based on certain traits. You want to determine the outcome of races. You want to then start new races, end new races. You want to operate maybe NPCs, non-player characters in the game, maybe like race cars, like programmatically, right? And this is how it works. And then this is another example which I personally know quite closely, which is like how does an automated liquidity manager on Uniswap v3, for example, work? It's the same stack. You got the browser, you got the sort of like the centralized backend components, and then again the blockchain, right? And here, for example, on the read side, you have I need to monitor deposits and withdrawals from pools. I want to monitor the historical prices of the particular assets on an decentralized exchange. I want to monitor the asset composition of a particular pool, historical returns, and so on. And then on the right side, what I want to do is I want to read that data, the deposit, the withdrawals, the asset compositions of particular pools, and I want to calculate certain variables with that, right? Maybe like a volume weighted average price, and then use that sort of data to then run market making models. These might be AI models, these might be just like regular models. And then based on the outcome of these models, I want to then place new bits and asks on Uniswap v3, for example, right? Which are then in case, again, like transactions that you want to send. And if you like abstract it away, this is basically how it like looks. And if I I've seen and talked to a bunch of Web3 projects, and right, and this is sort of like the different services that they usually rely on. You have the storage services. You got the indexing services in the bottom right for you, which are reading the data from the chain, and then they're storing it somewhere in a decentralized database, for example, or like a centralized database. And the indexing service tries to keep up with the events in the state and makes it easy to query historical data. And then you got the write applications, which is basically, okay, doing computation on that data that are indexed and maybe enriching that data, that on-chain data, with more data, like off-chain data, which you can get from Web2 servers, for example, and then based on that executing transactions. And really, if you look at most applications from market making, decentralized market making applications to Web3 games, they usually sort of, on the high level at least, follow that sort of structure. And that's why we can sort of say that the Web3 application rely on these 4 key backend services. That's how we sort of call them, which is one, indexing, on-chain data and events, storing that data somewhere, running computation on that data, maybe also enriching the data with off-chain data, and then executing transactions based on them. They're sort of like the 4 services that every Web3 project needs, or like most. And usually what I see is that most of these applications, they still run them, they still custom build them and run them themselves in-house. And this has several problems, and it's not only like very costly and time consuming, but there are a bunch of drawbacks here, which are, first of all, the censorship, right? Many applications, be games, social media platforms, for example, if you can put political pressure on these projects and they have to switch off their servers, then basically the application, even though the smart contracts themselves might be on-chain, are basically rendered useless because their services are not available to the public anymore, and only like sophisticated actors can actually interact with them, maybe programmatically via the command line or so, right? Then you have a huge replication of non-business specific work that every project has to do. They have to build their own infrastructure themselves, run it, face the same issues, read the same blocks, query the same data. It's just like very redundant and replicative. And then usually what that means is if they don't have the right resources behind these projects, the result is a very bad UX because you lack the reliability and scalability most of these services, and especially in fast chains like Polygon, etc. People have like huge problems when they have to deal with like 200 block deep reorgs and stuff like that. You usually don't have time to optimize for these little things. And then especially if you want to go multi-chain as an application, you don't have to not only run and maintain these things like a Polygon, you have to do it on 10 different other chains, for example, and it just becomes exponentially more complex to do. And so this is basically what we at Gelato want to help these projects with, right? We sort of see ourselves as Web3's decentralized backend and want to help them outsource these core backend services to a network that deals with that on their behalf, and they can only focus on building the application business-specific logic. And the goal here is empower builders to create truly reliable, user-friendly, and scalable Web3 applications. This is sort of like how we would see it right now in the stack. These are the 4 different services. And Gelato is really right now very much focused on sort of like the writing side, the computation side of the stack. So basically the on-chain computation automation. It's actually how we started with, and we are now since a couple of weeks ago, we also offer off-chain computation automation, which I will go into in a bit, and then transaction relaying, like using Gelato as an infrastructure to actually write to the chain in a very scalable and performant manner. And then, of course, you still need the data indexing and then storage and querying parts, which right now Gelato is not focused on. And yeah, this is just an example or like a sort of overview of Gelato works, how Gelato works. In case you don't know, there are basically 2 parties here. One are the validator nodes, and they are the ones that are running all that computation, that are basically reading the data from indexing systems and then running computation on this. And this computation might be, hey, can I execute this limit order on Uniswap or PancakeSwap right now? Or should I rebalance that LP position in this concentrated AMM, or just something easy like, shall I rebase this algorithmic stablecoin on Ethereum, right? And whether this computation is run and when this is run, and the result is yes, you should actually execute that, then these nodes come to an agreement, and say sign a payload, which is, hey, this is the transaction that should be executed. They sign it, and they send it to the executor nodes. The executor nodes are just like nodes that live on all the different chains that Gelato supports. I think we're on 14 different chains today, only EVM. And they then get them mined and get paid for actually signing that transaction. And then there's an entry point on each of these chains that we support. And then from there, a target smart contract and a target function with a specific signed payload is being executed. And then something happens, like a limit order gets executed, or a token, an algorithmic stablecoin gets rebased. Yeah, and so what we started with really is we started automating smart contracts like 3.5 years ago or so, and there was not much going on back then, and was super simple, and all of the use cases literally only required to sort of validate certain on-chain conditions and then execute on-chain transactions with that, and there was no need for any sort of external data in that. But this is really a big limitation, because applications are getting more and more sophisticated, and with that they require more and more data that might not be available in the particular chain that you want to operate on. And to overcome this limitation, what we have seen from talking to our customers, which are Web3 projects and the users of Gelato, is that they just run their own centralized infrastructure again that does exactly that. And this, of course, is highly unscalable. And yeah, if it goes down, sort of like the whole application logic of that particular use case won't be executed. And that's why we came up with a way of how you can use Gelato in conjunction. Like, you don't even need someone else, but you can use it, for example, in conjunction with Oracle protocols that do not, like most of them do today, just like take data and just post it repetitively on chain, but just like take data, agree on it, sign it, put it somewhere on like IPFS, Arweave, or whatever, and then be able to query that on demand and put it on chain. And how this actually works is, you as a user, you used to define like smart contracts, and then Gelato basically checks these smart contracts, and the smart contract itself returns the data and defines like the logic here. But what you can do now is you can write, let's say, a JavaScript file or like a Rust file that includes arbitrary HTTP requests and does computation, and then it tells Gelato when to execute something and what data to use. This code gets compiled, you can push it to IPFS and then tell Gelato by creating an on-chain task that it should run this particular file in a Docker container, and then run the logic inside of these nodes to then automate whatever you want with calling arbitrary off-chain data. An example for this, for example, is like a lightweight on-chain price feed. You can take existing Oracle networks that just agree on data, then post that data to IPFS on the right side, and then you can create a task that tells Gelato, hey, check that signed Oracle price feed, or that signed price feed on IPFS, and if it deviates from whatever price feed on chain by more than 2%, hey Gelato, please take that data from IPFS via an HTTP request and then push it on chain for me. And so you can really build your own oracles with an Oracle service that just like works by pushing data on IPFS, and you instruct Gelato to just put it on chain for you. And this is how it works. You just write basically this sort of function here. This is now written in assembly script, which then returns two things: a boolean, which is true or false, true, please execute, false, please don't execute, and some data that Gelato should use to execute it. And how trustless this data is, you can define yourself. You can call these you can do HTTP requests to servers that sign certain data, and then you can take that data, you can put it on chain, you can have a verification function in the smart contract to check who signed that data. That might be an Oracle network or first-party Oracle or whatever you want to do. So it's basically like a bit like serverless functions. And yeah, I think we're already coming to an end. This is, by the way, an ecosystem of all the projects that work together with us and use Gelato for one service or another. I think we are over 200 to 300 now, and growing every day. And it's awesome to see a bunch of really cool use cases being utilized. And we believe this new off-chain capability will bring significantly more in the near future. And yeah, that's already it. Thanks a lot for listening. Looking forward to build Web3 together with you guys. And yeah, thanks.